Welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze a D-type anchor shackle for its modal analysis. We will figure out the natural frequencies of the shackle at which it will show a particular amount of deformation and vibration which could be harmful for the shackle. So we will want to know that what is that frequency that we need to avoid resonating our body with. So we will start by double clicking on modal module. We'll first go to engineering data and add the material, that is alloy steel. We will study for two different materials. One is alloy steel and the other is stainless steel. We'll first add the material. The value of density is 7.86 gram per centimeter cube. If you want to write in terms of kg per meter cube, it is 7860. Next, we'll go to isotropic elasticity. The value of Poisson's ratio is 0.29, and we need to add the value of Young's modulus, which is 207 gigapascal. So one material has been added. Next, we will go to engineering data sources, general materials. Here, I'm going to choose stainless steel as the material. Then I'll go to project and update project. Next, I'll go to geometry and right click. I'll import the geometry. Next, I'll go to model and double click on it. I'll first go to geometry and hide the shackle pin. And I'll go to the D shackle and I'll change the material first to alloy steel. Then I'll go to mesh and I'll change the sizing to fine and update. Next, I'll go to model and I'll insert fixed support at these ends. Next, I'll go to solution and I'll solve. Next, I'll left click and then right click and select all. Again, I'll select create mode shape results. You can see all the 6 deformations have been obtained. I'll go to solution and solve. Now the number is 6 because when you go to analysis settings, you will see the max modes to find is 6. So that is why we have got 6 deformations. So we'll first see the deformation of mode 1. The frequency is 2832.5 Hz. You can see to the right here. Also, you can read the value here. The value of deformation is 245.18 mm. The value is very high. It is 24.5 centimeters. So also is the value of frequency, which is quite high. So we will have to make sure that this natural frequency is not touched by vibration of any other system around, such that if there is resonance, there will be a motion of this sort and this much amount of deformation will occur in the D shackle. Next, we will go to total deformation 2. You can see the pattern of its motion. The value of deformation is 177.49 mm and the frequency is 4674.3 Hz. Next, we'll check for deformation 3. Here the deformation is 259.1 mm, which is the highest value, and the value of frequency is 7355.1 hertz, which is quite a high value, and this will be the pattern of its motion. For deformation 4, the corresponding frequency is 15,973 hertz, and the maximum deformation is 261.72 mm. You can check its pattern of motion. Then we'll go for total deformation 5. Here the value is 185.52 mm for a corresponding frequency of 15,999 hertz. This is how you can animate and check the result. And for the final deformation, the value of deformation is 193.35 mm and the corresponding frequency is 23,284 hertz. You can see its pattern of motion, which means 19.3 centimeter will be the deformation on the body. This is really large, and so is the frequency. Obviously, this high frequency is never touched, but if at all it is, then this will be the sort of deformation on the body. Now we will change the material and see for stainless steel what happens. Accordingly, we can decide which material would be preferable. When we went for structural analysis and thermal analysis, alloy steel was the preferred material. Now in this case, let's see which is the preferred material. When you see the first deformation, the value is 246.96 mm and the value of frequency is 2755.8 hertz. The pattern of its motion will be the same for all 6 of them. So it's the first one. When you go for the second one, the value of deformation is 178.72 hertz and the value of frequency is 4548 hertz. For the deformation 3, the value is 261.24 mm and the value of frequency is 7129.3 hertz. You can again check its pattern of motion is same as that of the third one of alloy steel. Now what we need to note is the value of frequency and the deformation correspondingly which is happening. For whichever material the value is higher, we will choose that material so that it is difficult to touch that amount of frequency and hence the amount of deformation would not occur. So this is the fourth one with 263.87 mm and 15,512 hertz as the frequency. For the fifth deformation, the value is 187.06 mm and the frequency is 15,552 hertz. For the last one, the value is 195.22 mm and the value of frequency is 22632 hertz. Now, if you want, you can change the number of modes from here by increasing or decreasing to whatever value you want to see. So you can just go to solution and solve. So what has happened is there's a repetition of values because you wanted to see 10 of them, 16 have appeared, which means the first 6 will be repeating. So you can just delete these ones. 7, 7 to 12 have deleted, so only 10 of them are remaining. And now the 13th one is the mode 7, as you can check here. And this is the pattern of its motion. You can see the corresponding deformation and the frequency over the body. This is for the 14th one, which is the mode 8 now. Again, you can see its pattern of motion. This is the 15th one, which is mode 9 now. And finally, you can have the 10th mode. You can check the value of frequencies here or from here and these are the values of deformation. So that's how you go for modal analysis of a D shackle. I hope you have understood the analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share, and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.